welcome back to Calculus. In this video, we're still working on rules for derivatives, but we're going to very specifically zoom in on the product and quotient rules. So the product rule, I have an example here for why it's not what you think it is. Okay, it seems like if you have two things multiplied together, then maybe you take the derivative of the first times the derivative of the second, and there is your answer. So I want to look at this little product. I want to take the derivative of x times x. Okay, that's a product, and so let's see what happens. We know that this is the same as the derivative with respect to x of x squared, and that is 2x, right? We drop the exponent down front, and we get a power that is 1 less, so we just get 2x. However, if we try to use what seems like it should be the product rule, where we just multiply the two things together, we get the derivative with respect to x of x times the derivative with respect to x of x, and those are both 1, right? The derivative of just x is 1, because we drop the exponent down, the exponent goes down by 1, which gives us 0, and anything to the 0 power is 1. So 1 times 1 is 1, and those are not remotely the same thing, right? 2x and 1, not the same. So the obvious product rule is not the correct one. We need a rule that actually works. So unfortunately, we can't just take the derivatives of the two parts and multiply them together. So instead, here we go, the product rule, and then we'll do some examples on the next board. If u and v are differentiable functions of x, okay, so again, we have u and v here just standing in as things that we know how to take the derivative of. Then the derivative with respect to x of u times v is equal to u, that first thing we know how to take the derivative of, times the derivative of v, the second, plus the second thing, v, times the derivative of the first. So we're going to think of this in terms of pieces. And we can extend this to as many pieces as we want. Let's extend it out and add a third piece, u times v times w. And what happens is we just do our derivatives one at a time. So this would be u times v times the derivative of w with respect to x. Okay, those first two with the derivative of the third. And then let's do u times w times the derivative of v with respect to x. Oops, I ran out of room. And then v times w times the derivative of u with respect to x. Okay, so we can extend it out to as many pieces as we want. Basically, you take the derivative of one of the pieces and multiply it by however many other pieces are there. So the most common is two pieces, u and v. So first function, second derivative, second function, first derivative. If you go past that, just remember one derivative at a time with the other ones multiplied. All right, so let's look at a couple of examples and really have some fun with this. Okay, one example of the product rule, I wasn't able to fit two, so we'll get another board for the next example. Again, I put the formula up here, or the product rule up here for us, just to look back at. I want to take the derivative with respect to x of x cubed times e to the x. Now, first thing to check, make sure it is multiplication. That's going to be really important when we get a little bit later into the chapter. It is multiplication. So we're good. So my first piece, one thing you can do here is identify your u and your v. Okay, you can identify those two separate pieces. And if you really want to continue on, I mean, I did it all here. You can see I did u times the derivative of v plus v times the derivative of u. But one thing you could do is you could find those two little derivatives. Okay, before you start, you could find those two little derivatives. So the derivative of u would be 3x squared, and the derivative of e to the x is just e to the x. All right, so I wrote it out over here, u times the derivative of v plus v times the derivative of u. Right, those are my parts, u and v. And you can see then we can piece it together. And like I said, if you want to do this first, it's not a bad way to go, because then you just go and you fill in the pieces. So here's u times the derivative of v plus v times the derivative of u. And then I clean it up. I'm always for sure going to bring this constant, this coefficient, into the front. That really has to happen. Don't leave that 3 hiding back behind the multiplication. Take it all the way to the front. And really, it's a lot nicer if the x squared also gets tugged in front of the e to the x. It just looks better. But for sure, that 3 really needs to come out front. So we get x cubed e to the x plus 3x squared e to the x. And isn't that fun? All right. Next board, another example. Okay, my next product rule example is going to have 3 pieces because I want you guys to see something like that. And actually, we're going to have a different way to do this one in the future, but for now, this is how we have to do it. So I wrote out the product rule for 3 pieces. Remember, it's just always take one derivative and use the other 2 pieces as multiplication. So here's my derivative. I want the derivative of e to the 3x. Now, obviously, at first glance, you're like, hey, where's the multiplication? I just see an e to the 3x. There are no pieces really multiplied together here. Yeah, that's true. But using the rules for exponents, e to the 3x is the same as e to the x times e to the x times e to the x. Remember, if you're multiplying things with the same base, you add their exponents. X plus x plus x is 3x. So I need that derivative. So I, over here, wrote out u, v, and w. I also wrote out their derivatives. And it's really nice because they're all e to the x's. So u, v, and w are all e to the x. Remember, the derivative of e to the x is e to the x. So we have everything we need. So I put it together. I went u, v, dw, dx plus u, w, dv, dx plus v, w, du, dx. They're all the same. And just like before, we can add these exponents. X and x and x makes 3x. There are 3 of these, so we end up with 3 times e to the 3x. So there is a different rule that we could use to get that one. It's called the chain rule, and it will be coming in a later section. And it can be a bit of a mess, so it'll be fun. All right, but for now, we're going to move on to the quotient rule. Okay, the quotient rule. If u and v are differentiable and the bottom, v of x, is not equal to 0, then the derivative of the quotient, this is the messiest one. This is gonna be one of the ones you have the most trouble probably remembering. So it is the bottom function, v, times the derivative of the top function, minus the top function times the derivative of the bottom function, all divided by the bottom function squared. All right, now unfortunately, because this one has a minus sign, order is going to make a big difference. Okay, with the product rule, it was a plus sign in between the 2 pieces, or between however many pieces you had. With the quotient rule, it's a minus sign, so order matters. So you're going to have to be able to keep it in the right order. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So one kind of way to remember that is low d high over high d low over low squared, right? Bottom piece times the derivative of the high minus the high piece times the derivative of the low, all over the low squared. All right, so let's look at an example. The real fun will come eventually when we can combine both the product and quotient rule into one problem. You're not going to like that. It gets big and ugly and messy. But for now, we don't have enough derivatives that we know how to do, really, to be able to have that be a thing. So for now, let's just do a basic quotient rule problem. Here we go. All right, so I just have this one example for the quotient rule. Definitely do the homework, and if you need to do extra homework just to get this thing sorted in your own head. So you'll notice I left the quotient rule on the board. The derivative with respect to x of u over v is v du minus u dv all over v squared. All right, so here's what I want to find the derivative of. I want to find the derivative with respect to x of e to the x over x cubed. 2 pretty basic little pieces, right? We know how to find both of those derivatives, which is good. I started by identifying the parts. Now, remember, the top is u, the bottom is v, and order matters. So the top is, or the u is e to the x, the v is x cubed, and then I took their derivatives. So du, or du dx, if you prefer, is just e to the x, and dv is 3x squared. Again, that exponent drops down in front, and we subtract 1. Once we have that, then we can start to piece it all together. So first thing I did was I just filled in all those pieces. right? We have u, v, and their derivatives. I just filled them in. So v is x cubed times the derivative of u minus u, which is e to the x, times the derivative of v, all over v, that x cubed raised to the second. So that's my derivative. I'm going to clean this mess up though, and you really do need to clean this up at least a little bit. So the first thing I did, well, the first term just stays, e to the x, or x cubed times e to the x. Again, I really like having that 3x squared in front, so I have minus 3x squared e to the x. It just looks nicer, and definitely the 3 has to be there. And then when you raise a power to a power, you multiply, so we get x to the 6th. So what I noticed then is that we can make this look nicer, and that's going to be really important in case you ever have to go on and do this with like product, or with, I'm sorry, like if you need the second derivative here, this would be not very much fun. What I notice is I have x's in both of these two terms on top. In fact, I have at least x squared. So I factored out the x squared, which left 1 in the first term, and then the x's are gone from that second term. The reason that was nice is because with that x to the 6th on the bottom, I can reduce, right? I can get rid of those 2 on top and get rid of 2 of them on the bottom, leaving x to the 4th. And so I have a simpler looking version. And yeah, there you go. So there you go. That's the quotient rule. Have fun. And if you really want a challenge, take the derivative of this mess. Okay? Right? This would be the second derivative. Go take the derivative. Let's look and see. Let's just look for a second. What's in this that you would have to do? We have a product rule here. This is just a constant multiple, so it's not a big deal. And we have a quotient rule. So there is a product rule in this and a quotient rule. Again, if you're going to do that, go ahead, try it. If you're going to do it, let the top be u and the bottom be v, and find those derivatives first, and then piece it all together. Okay, so that would be big and messy and a lot of fun. So, all right, have a great day.